All right, chapter 8 is about confidence intervals. So now that we've learned about all the different parts of statistics, we're going to learn how we can use those to make estimates about the population based on our sample. And one way to do that is with a confidence interval. So, what a confidence interval is when we're basing it on a proportion using the distribution interval is we center this based on a point estimate. So we have a statistic from our sample. So we have a proportion based on our statistic, and then we're going to go above and below that a little bit and say, hey, within this interval, we have a range that we think the real population estimate is. And then that plus or minus is our margin of error. So you'll see things that have samples like means and errors and confidence intervals. So your sample mean is still your X bar. E is going to be your margin of error. So that's how far above and below that mean we are. And then the interval will be written like this, 5 being the lower, 15 being the upper. So let's look at a couple so that makes more sense. So suppose we've collected data from a sample. We know the sample mean, but we don't know the mean for the entire population. So we want to take that sample information and make an estimate for the whole population. So our sample mean is 7. So we figured out, we asked these people, the mean of that sample was 7. We have a margin of error of 2.5, meaning that could be within 2.5 above or below that sample mean is where the real one probably is. The real one being the population. So find and interpret the confidence interval. So to find that, we take our mean, our sample mean, and we add 2.5. So we get 9.5 as the upper limit. And then we're going to subtract 2.5 to get the lower limit. So our confidence interval would be from 4.5 to 9.5. So that's the confidence interval, from 4.5 to 9.5. Now, if our confidence level is 95%, we use that to interpret. And so the interpretation is that we are 95% confident, or we're 95% sure that the population mean, or proportion, that the real population mean is between 4.5 and 9.5. So we use our sample and our margin of error to pick a range. And then the confidence level is how sure we are the population mean is in that range. So why don't you pause the video and do the U try. So if our sample mean is 15, error bound is another way to say margin of error. So if that's 3.2, we're going to add 3.2. So we get 18.2. And then we're going to subtract 3.2. So we get 11.8. So our confidence interval is 11.8 to 18.2. And then this just says what is the confidence interval. So it would just be 11.8 to 18.2. And then if we were to interpret this at like 95%, we'd say we're 95% sure the population mean is between 11.8 and 18.2. Or whatever percent they give us. So visually, we take that sample mean, and that would be in the middle. And then whatever percentage of confidence we are, we're that percent sure the real mean is somewhere in that range. So remember, when you get a sample, you're going somewhere in between, and you always could get that outlier in your sample. So that population mean could be anywhere because your sample could be somewhere over here if you had an outlier. So that you're never 100% sure. So you use your sample to make an estimate about the population. And then based on what you do, you're going to use some math to come up with an interval, and you say, hey, we're pretty sure the population is somewhere in this range. Now, your calculator will do some math to calculate those intervals based on what percent you are. So in the calculator, if you hit the stat button, same button we've been using all along to enter our data, then you arrow over, instead of to calc, keep going one more to test. So to calc, over to tests. Then if you scroll all the way down to Z interval, and there's multiple that we're going to use as we go through this, but there's different ones. So there's Z interval, T interval, all kinds. Depending on which one we're doing, you'll use the interval to make the one you want. Because these up here that we just did with the examples were just quick things. But depending on what data you have and what you're doing, specific intervals will give you different information. So if you go to Z interval, then you have an option of data or stats. So if I give you a list of data and you put it in L1, you're going to use the data option and the calculator will use the data. If I just give you information like the standard deviation and the mean and the amount of people, you're going to use stats. So it'll depend which column you use based on what information you're given. And we'll go through and do some examples. So let's look at how we would make one with actual data instead of just some numbers. All right, so suppose scores on exams and statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. So we know the population deviation is 3. And we know it's normal. A random sample of 36 scores is taken. So that's N. N is our sample size. And we're given a sample mean of 68. Find a confidence interval estimate for the population mean when we are 90% confident. So we want to be 90% confident. So this is the information we're given. So whenever we're asked about a population mean, so we want to know what parameter. So these are the things we have to ask ourselves. What parameter are we looking for? So remember, parameter goes with our population. Are we looking for the mean? Yes, they want to know about the mean. Then we want to know, do we know the population deviation? Do we know population deviation? Yes, they told us this here. So that means we do Z interval. So on our calculator, we're going to do stat. We're going to arrow over to test. So stat button, arrow over to test, go down to Z interval. And we're not given a list of data. We're just given some stats. So we're going to choose the stats option. Then we enter what it asks for. It asks for the standard deviation. So we put that in as 3. It asks for the sample mean, X bar, so we put in 68. It asks for N, that sample size, so we put in 36. And then it asks for the C level, or the confidence level, which is 90%, so we're going to type that as a decimal, or 0.9. And then we go to calculate and hit enter. At the top, you get the parentheses. So the parentheses is your confidence level, 67.18 to 68.82. That's our confidence interval right there. For the interpretation, we would be 90% sure that the population mean is between 67.18 and 68.82. So the calculator does that math for you and gives you the confidence level. So if you're looking for the mean and you know the population standard deviation, you do Z interval. So why don't you go ahead and do the U-try? So average daily pizza times are normally distributed with an unknown population mean and a population standard deviation of 6 minutes. A random sample of 28 pizzas, so that's N, is taken and has a sample mean of 36, that's X bar. Find a 90% confidence interval for the population mean. So same thing, population mean, and we know the standard deviation, so we're going to do Z interval. And we're given a bunch of stats. So we do stats. Our deviation is 6. Our mean is 36. Our N is 28. And our confidence level is 90, so 0.9. Go to calculate. And our interval is 34.135. 135 to 37.865. So that would be the confidence level. All right. Example 3. So this one we have a table. So this is going to be a data one instead of a stats one. All right, the specific absorption rate for a cell phone measures the amount of radio frequency absorbed by the user's body when using a handset. Every cell phone emits RF energy. Different phones have different SAR measures. To receive certification from the Federal Communications Commission, FCC, for sale in the U.S., the SAR level for a cell phone must be no more than 1.6 watts per kilogram. The table shows the highest SAR level for a random selection of cell phone models as measured by the FCC. Use the data to find a 98% confidence interval for the true population mean of the SAR. Assume the population deviation is 0.337. So they give us the population deviation and they give us a list of data. So that's enough to say, hey, we're going to do Z interval. So this time we're going to put all of our data in L1. So we hit stat, enter, and then we're going to type this data in L1. So 1.11, 1.36, 0.74. So I'm just going to type all of this data right in my L1. Okay, I'm just going to double check them quickly. 38395, 352, 82, 336, 14, 867, 1313, 418, 43. That's 1.43. Okay, 34. No, that was right. Okay. 13674. This should be 148. 134. Okay. Then I'm going to do the same thing as before. Stat, over to tests, Z interval. But this time I'm going to choose data because I have a whole bunch of data in there. I'm going to enter the standard deviation as 0.337. And my list is going to be L1 because that's where I typed it. Frequency should stay 1. And my confidence level is 98%. So I should put 0.98 here. Then I'm going to calculate just like before. And I get 0.871 to 1.157. So that would be the confidence interval. So I'm 98% sure the average, the mean of these numbers, but the population is between 0.871 and 1.157. So same process, But I don't have to find the sample mean because I can just put it in the calculator and it'll do it for me. So why don't you try the U-try? All right. So 1.48, 1.53, 0.8, 0.68, 1.15, 1.4, 1.36, 1.24, 0.57, 0.462, 0.2, 0.36. Oh. Nope. 869. Okay. 869. 8697 73 1.3. Oh goodness. 868 1.5. And then the benefit, notice my last two aren't in the same order. When there's only one set of data, the order doesn't matter. So I could just add the missing one to the end. Then I'm going to go to my tests, my Z interval, leave it at data. Population deviation is still 0.0337. List 1, and this time we want 93% confidence, so 0.93. Calculate. I get 0.939 to 1.212. That is not what I got when I did that on my calculator. So let me see what I did differently with my notes here. 7, 869, 73, 133, 0.3. Okay. Stat, tests, Z interval, calculate. There we go. That is better. So even when I double check, I forgot a decimal. So 0.804 to 1.077. There we go. Find the confidence interval. Perfect. All right. So that's how you do it with data versus stats. Now let's look at some questions. Repeat example 2 with a 95% level of confidence. What happens? So instead of doing example 2, that's on the page. So let's do, instead of doing the examples, I'm going to do the U-try because we have it right here and we don't have to keep flipping back and forth. So the U-try 3 with a 95% level of confidence. So right now, this was at 93%. 93%. So if I do it at 95%, I'm just going to go stat tests. I don't have to retype it, but I'm going to change 93 to 95 and calculate. 0.792, 1.088. That's at 95%. What happens? So the lower went a little bit lower and the higher went a little bit higher. So it got wider. Example 2 with a sample size of 100. Okay, so now that's why we did the examples. So I'm going to go up to this U-try so I don't have to flip. So up here, we had a sample size of 90. Nope. We had a confidence level of 90% and a sample size of 28. So I'm going to change that sample size to 100. So I'm going to go stat, tests, Z interval, and I'm going to re-enter this data. So my standard deviation was 6, my X was 36, but I'm going to change my N to 100, put this back down to 90. That changes this to 35.01, 36.99. So it looks like 34 went up to 35 and 36 went down to 37. So it's a little bit skinnier. And now change that to a 95% level of confidence. So this was n equals 100, but still 90%. So now we're going to do the same thing, stat test z interval, but we're going to change this to 95% confidence. Now we go 34.82 to 37.18. So that's n equals 100 and 95%. So now it got a little bit wider again, but not quite as wide as the first one. So notice from the original question to here, when I just increased the number of people I asked, our interval got thinner. So when I asked more people, our interval got shorter. So I got more confident, I guess. Not more confident, it's the same percent, but that same level of confidence could have a smaller interval. So I knew more precisely where my number was. So I asked more people, which means I had more information, so I could narrow down where my answer was. So I'm still 90% sure, but I'm 90% sure in a smaller area. When I go to increase that percentage, so now in the pink, I want to be 95% sure, that area gets a little bit bigger again. Because to be more sure, I have to widen the area where I think it fits. So asking more people shrinks the area because you have more information. Increasing your percentage widens the area because you have to increase that to be more sure. That's what those pieces of information are telling you. So it's just about, what do you know and what does that information do to your pieces of knowledge. So let's look at a couple more. Now we're going to go the other way. Suppose we know that a confidence interval is 67.18 to 68.82. We want to find the error bound and the sample mean. Error bound is another word for margin of error. So the sample mean is just the middle of that. So we're just trying to find the middle. So what can you do? Add them up and divide by 2. So do 67.18 plus 68.82 divided by 2. You're just literally finding the middle. Plus 68.82 divided by 2, 68. That's your X bar. That's your sample mean. To find the error, you just subtract that middle from one of the ends. So we take the upper end, 68.82, subtract the mean. That's your error bound. That's your margin of error. So the middle, the mean, the average, that's your sample mean. And then pick one end, subtract it from the mean, and that's your error bound. So why don't you do the U try? All right, so we're going to find the middle. So 42.12 plus 47.88 divided by 2 gives us 45. So that's the middle. And then if we did 47.88 minus 45, we get 2.88 for our error. So that's how you can work backwards from the confidence interval to find the information for your sample. All right. Now, the last part of this section is if I know what I want, how many people do I ask? So for example, here's the formula. N equals z squared times the standard deviation squared divided by the margin of error squared. So Z is a critical value based on the confidence level. So if you want to be 90% confident, your Z is going to be 1.645. And this is given to you on the test note sheet. I just didn't type it on this one for some reason. If you want to be 95%, it's 1.96. 98% is 2.33. 99% is 2.575. These are the Z-scores that go with the normal curve. So this is the same normal curve we've been using, the same standard deviations, normal bell curve. These are just the Z-scores that go with that curve, with that number of standard deviations away, thinking we're going to be in the middle. So if you're talking, 90%, you want 90% in the middle, which means you want 5% on this side and 5% on this side. So that makes 10%. It's just the Z-score that would go with those two values. That's where this comes from. It's not a magical number. But rather than have you find it every time because it never changes, that's where those come from. So if you're doing 95% confidence interval, you're going to use this value for Z in here. So those are given to you because that's what we're always going to use. So if I say, hey, I want to be 95% sure that when I make my inferences on the population that I'm 95% sure I'm using the right information, how many people should I ask? Then you know how many people you need to ask in your survey if you're trying to develop something. This is the formula you use going backwards. So the population standard deviation for the age of Foothill College students is 15 years. If I want to be 95% confident that the sample mean age is within 2 years, so I want my margin of error to be within 2. For the true population mean, how many randomly selected football players must be surveyed? So if I'm 95% sure, my critical value, 95, is 1.96. So the problem gives me the standard deviation, the margin of error, and the percent. I use the percent to get my Z, and then I plug them in. So N equals Z squared times the standard deviation squared divided by the margin of error squared. So I plug this in the calculator, 1.96 squared times 15 squared divided by 2 squared, and I get 216.09. And then no matter what you get, you always go up to the next one. Even if it was like 216, round up, 216.00000, you always round up to the next number. So we said that was 15. We were 95%, which brought us to 1.96, and E was 2. So then we plugged those in. Uh, 15 squared, my lord, over 2 squared was 216.09. And then we said round up. So we would ask 217 people just to be sure. And then our information would give us a confidence interval with a margin of error 2. And we would be 95% sure the real population mean is in that margin of error. So you do you try. All right, standard deviation is 3 inches. We want to be 95% sure. 95% goes with 1.96. And we want to be within 1 inch, so our E is 1. So we plug those in. So Z squared times standard deviation squared over margin of error squared. So we get 34.57, which means we're going to ask 35 people. So that is section 8.1. It's an introduction to confidence intervals using the Z interval. So when we want, so the Z interval, quick review, is when we want the mean and we know the population standard deviation. Let me know if you have any questions.